please turn off your cell phones. I have a couple of announcements for you today. First of all, there is the Beading Club upstairs, the craft fair, taking place from 1 to 5. So please do drop by and buy some Hanukkah gifts, some Christmas gifts. There's some beautiful jewelry, handmade cards, wreaths. So head on up there in the cafe. Also, there's going to be a concert on December 18th at 2 o'clock. Registration must be done on our website. It is Ensemble Caprice, 2 p.m., December the 18th. And now, without further ado, here's Dr. Joe with Science Demystified.
Hey, what question you think I've had dozens of times in the last couple of weeks? What? Dr. Oz has been a few questions too. Yeah. Something else. No. The question that I've had is, should I be throwing out my black spatulas and spoons in the kitchen? The answer is no. It was a scare based on a mathematical error. The people who wrote that the paper that demonized these black plastics multiplied wrong, and the amount that they came up with what leaches out of those plastics is actually 1/10 of what they calculated. Anyway, I just wrote a Gazette column on that, so you'll see it next week. All right. Well, for today, the topic is hormones. What are they? Basically, they're chemical messengers. That's what hormones are. They are synthesized in the body, they get into the bloodstream, and they trigger some reaction somewhere else in the body. And there are some interesting stories to be told about hormones, and we will try to tell them. We'll start by turning back the clock, because it's always interesting to look at things, historically, and see how knowledge has evolved. So we're going to start back in the 18th century with John Hunter, one of the famous physicians in England at that time. And he has a museum, actually, in England, the John Hunter Museum, with a lot of his medical equipment and diagrams of the dissections that he did. Anyway, really interesting. But in our context here, what he did was he removed the testes of roosters and observed that their combs shrank. Now, that's pretty interesting. You manipulate one part of the chicken and something happens somewhere else. But he didn't go any further than that. However, following on this, Arnold Berthold, another English physician, did. So he knew about Hunter's experiment of removing the testes of a rooster and seeing the collapse of its comb. And he decided to go one step further. So he took the testicle that was removed from the rooster and he put it back into the rooster's body, into its abdominal cavity. And the rooster showed normal sexual behavior and comb development. Well, that's a pretty interesting observation. How can you possibly explain this? Well, if you think about it a little bit, the only way that this can happen is if the testicle that was put back into the body cavity was releasing something that caused the comb on the rooster's head to stand up. Now, of course, he didn't recognize this as a hormone, didn't coin the word hormone. That was coined much later. Hormone comes from the ancient Greek, to stir into action, because that is exactly what hormones do. They stir something else in the body into action at a place remote from where it is generated. Well, in the 1800s, there was a lot of activity along these lines. Thomas Addison, another British physician, focused in not on the testes, but on the adrenal glands, which are located on top of the kidneys. And he noticed something very interesting. When he did autopsies of patients, because that was quite common, when someone died, you wanted to learn what they died from. And he noticed that when he did these autopsies and he found that the adrenal glands were small, that they had atrophied, this was in patients who during their life had complained of poor appetite and low blood pressure, weakness, anemia, and bronze skin. So once again, the idea here was that the adrenal glands must be releasing something into the bloodstream that causes activity somewhere else. And if there's a deficiency of whatever this is, then that has consequences. So he thought that the adrenal gland must be releasing something that prevents those symptoms. Because when the adrenal gland isn't working properly, that's when those symptoms appeared. So the conclusion was that when it was working properly, then you wouldn't get those symptoms. Well, it took another, about 50 years until that something was actually isolated. Today, of course, we know what the adrenal gland produces. It produces adrenaline, also called epinephrine. Those are interchangeable terms. And it became pretty clear that when someone had low blood pressure and you injected them with adrenaline, the blood pressure normalized. Today, of course, this is a classic part of medical treatment. In an emergency, when someone's blood pressure drops, such as due to an anaphylactic reaction, which can happen with an allergy, what is it that you inject? Of course, you inject epinephrine or adrenaline, the EpiPen. And the EpiPen is absolutely life-saving, right? It's actually an automatic injector. And all you have to do is put it next to your flesh, press the button, and it automatically injects a dose of adrenaline. And it can cause a virtually miraculous reversal of anaphylactic shock. Classic example, of course, is a peanut allergy. And it's really quite unbelievable how little of anything peanut can cause such a reaction in people who have peanut allergy. It's a few milligrams that can have a devastating effect. And it's really remarkable how just using an EpiPen can essentially bring someone back from the brink of death in just a few minutes. But if anyone ever has to use an EpiPen after it has done its miracle, you still have to go to the hospital because there can be a rebound effect when the adrenaline wears off. That's why the EpiPen kits usually have 2 injectors, so that if something happens on your way to the hospital, you can inject once more. And it's critical for people who have potential anaphylactic reactions that EpiPen has to be within reach. It can't be locked away somewhere. And I always tell our students this story whenever we talk about allergies, because it's such a frightening story, and it really alerts them to the importance of having an EpiPen. And actually, it's quite a significant percentage that have EpiPens. I know, but whenever I ask in class, a class of 600-700, there will be 4 or 5 students in there with EpiPens. And once they've raised their hand, the next question I always ask, and where is your EpiPen? And some of them will say, oh, it's in the car, or it's in the locker, or whatever. And then I tell them the story. It's a story that goes back about 20 years, and it happened to an engineering student of ours who knew that he had an allergic reaction to peanuts. And of course, when you know that, you always question everything. And he was in the cafeteria in the engineering building, and there were cookies. And he asked the lady behind the counter, what are these cookies? And he said, oatmeal. He said, well, for sure, there's no peanut. That's no, these are oatmeal cookies. Of course, you never trust someone serving you from behind the counter to know something like that. So anyway, it turned out that it did have some remnants of peanuts. He had a reaction right there, and his EpiPen was in the locker, maybe 100 feet away, a locker that he shared with his best friend, who was with him at the time. And he rushed to the locker, and believe it or not, in his panic, he couldn't remember the combination, and they couldn't get it open. So at that point, when I tell the story, the students who had their hands up, who said that their EpiPen was somewhere else, immediately go and get it. So they learned the lesson, and it's a terrible story, but I think it's one important one, because you got to have it near you. You don't have the time. It's just amazing, how quickly your circulatory system can collapse during anaphylaxis, and your blood pressure drops dramatically within seconds. You may remember that we had another terrible such episode here. This was not that many years ago in a summer camp, where a boy on a canoe trip had a reaction because the sandwich it was a cheese sandwich, but apparently they had used the same knife that they used on peanut butter, and he had a reaction in the canoe, and the EpiPen was in the doctor's office in the camp, which is ridiculous. And of course it had a tragic end, and the doctor was sued for that. Justifiably, because that should never be. And now they have these little belts that even children can put around their leg or their waist with the EpiPen, so that it's always with them. Anyway, so that's the story of adrenaline. Now, as we continue the evolution of our knowledge of hormones, we're going to make a little stop with Charles Brown-Séquard, who was an eminent physiologist in the 1800s. He was actually born in Mauritius, but he did his education in France and also in the United States, and he was certainly eminent. In fact, there's a condition that is named after him. And this is, it's a rare condition, but it's called Brown-Séquard syndrome. It's a very interesting condition. It occurs when your spinal cord is damaged, but only on one side. And the consequence of that, as you can see, is loss of pain and temporary solution and temperature loss on the one side, and you have motor control loss on the other side. And this was discovered by Brown-Séquard in the 1800s. And the interesting thing is the way this was discovered. He came from Mauritius, and the main crop that is grown in Mauritius is sugarcane. And it was the sugarcane workers who were afflicted with this. Why? Because when you cut the sugarcane, you're always swinging like this, and you damage your spine on only one side because you're always turning the same way. Very interesting that he was able to make that observation. And then, based on the anatomy and doing dissections, he concluded what was happening there. So I tell you that part of the story because the rest of his activity is somewhat questionable, but this certainly was not. So, he was a very, very legitimate scientist. However, he was also into this business of what testicles can do. But he wasn't working with roosters. He was working with dogs. and he concentrated on their appendage. Now, he knew that when you remove the testes from an animal, the animals tend to get sick more quickly. He also had observed that eunuchs in Egypt, who were the keepers of the ladies in the harem and were routinely castrated to prevent them from inseminating any of the women. Only the Sultan was allowed to do that. And they suffered from all kinds of illnesses. So Brown-Séquard concluded that the testes must be producing something that prevented illness and something that conceivably could be invigorating and healthy. So he did something very interesting. He experimented on himself. He became his own guinea pig, as it were, and he injected himself with the macerated testicles of a dog in an attempt to rejuvenate. Why did he want to rejuvenate? Because he was in his 70s and he had just married a lady in her early 30s. And he was concerned that he might not be able to fulfill all his requirements. So he decided to do this. And he injected himself with the extract of the dog testicle and claimed that he felt young again. And because of his fame, which had already been established because of all the research he did on diseases and the Brown-Séquard syndrome, etc., when he gave a lecture about this to the Physiological Society in France, word spread very quickly. And you know how it is when charlatans see something with which they can make money, they immediately jump on that. So right away, there were people who started to sell extracts of animal organs, saying Brown-Séquard. Brown-Séquard had nothing to do with this. I mean, he just experimented on himself. But here were these, companies selling extracts of animal organs. New York, of course, the Americans are always the first ones to get into any kind of quackery. And so there it was. Some companies were even selling something that they called Sécarine, named after Brown-Séquard, even featuring a picture of him. He had absolutely nothing to do with this. The one great remedy of the future will undoubtedly be the serum. The mere fact that scientists are able to transfer energy from one animal body to another is sufficient to arouse enthusiasm among doctors. Well, not everyone was so enthusiastic about this, but Brown-Séquard certainly did have his followers, because you have to put yourself into the context of the times. There was not very much known about how the body functioned at that time. So it was totally conceivable that his idea was sound, that injecting an extract could do something. Well, one of his followers was Serge Voronov. The name Serge sounds French. It was Francisized. He was actually Russian. He was Sergei. And born to a Jewish family in Russia. And at the age of 18, he had enough and he emigrated to France because of persecution in Russia at that time. And he got a medical degree in France. And he became a devout follower of Brown-Séquard, believing that there was something magical in the testes that could be used to rejuvenate. But he had an idea that to him sounded even better. Instead of injecting an extract of some animal into a man to try to rejuvenate him, why not take a testicle or part of a testicle from another man and insert it into the scrotum of the recipient and let it do whatever it may do? Sounds pretty outrageous today, but it didn't sound so outrageous at that time. And indeed, he made a deal with the French government for getting these testes that he was going to use. From whom? From executed criminals. At that time, the classic execution was hanging, which did not destroy the other parts of the body. So he made a deal with the French government, and he got the testes of executed criminals. What did he do with them? He sliced them up, and he inserted slivers of this into the scrotum of men, and there were many men willing to do this. You know, even today, men are willing to do anything to try to rejuvenate. And so he inserted the slices of testes into a scrotum, and this was supposed to rejuvenate. Of course, he never really did any clinical trials, but certainly there were a lot of men who were very satisfied with this, because the placebo effect is very potent, as it were, right? And if you think that something is going to do you good, very often it does. So his business was expanding. The big problem was the raw material, because there were not enough criminals being executed to meet the demand. So what is the next best thing? He thought the great apes, which are our close relatives. So he started to do his experiments of transplanting from chimpanzees into men. And he actually started a farm in Italy to raise the chimpanzees that he would use. And he would take their testes and implant either the whole piece or just slivers of it into men. And here's an actual picture of him doing that. Right here, he is removing the testes from a chimpanzee. And as you can see, I mean, this was a medical procedure. You know, this was not some outlandish thing at that time. He wrote a book about this, and there it is, Rejuvenation, according to Voronov, which was extremely popular. And as you might also imagine, the media ran with this story. It says, monkey glands can make Superman. This comes from Vienna. Dr. Serge Voronov of monkey gland and rejuvenation fame announced today he was confident he could develop a Superman if he were permitted to transplant chimpanzee glands into a 10-year-old boy. If any mother would entrust her child to me, she might be the means of establishing a new type of human far superior to the normal man, said. Of course, it was an ancestor of Trump who was willing to do this. So there you have the explanation for what we have seen. Okay, anyway, of course, nobody was willing to do that, but there was a lot of publicity about Voronov, and there were books written about him, serious books, The Secret of Voronov and Rejuvenation. Interesting enough, there was even a cocktail in Paris that was named after him, the monkey gland cocktail. It's still available. You can order it at some bistros in Paris. It does not have monkey glands in it. They just capitalized on the name, and you can actually see here what there is in it: gin and orange juice and absinthe and a dash of raspberry or other sweet juice. So it maybe tastes very nice, but it was certainly named after the whole monkey gland business that was initiated by Voronov. But as I said, not everyone was enamored of this. And certainly many members of the medical community thought that this was nonsense, including Sir Arthur Conan Doyle, who, of course, was the creator of Sherlock Holmes. And he was a medical doctor, luckily not a very good one, because it was while he waited for patients to come in his office who never came that he had time to write the Sherlock Holmes stories. And had he been a good doctor, probably would not have the most famous character in English literature. But anyway, he was by training a physician, and he didn't think very much of this whole monkey gland business. And he decided to make fun of it, which he did in one of the classic Sherlock Holmes stories, which was The Adventure of the Creeping Man. And Sherlock Holmes is called into this case by the children of an aging professor of physiology who marries a young woman. And his children are surprised. They go out one day into the garden and they see him climbing a tree and swinging from limb to limb. And they don't know what to make of this. So this is when Holmes is called into the picture to try to solve this, this business. And he does. And it turns out that the professor had been injecting himself with monkey gland extracts and made a monkey of himself, right? And this is how Conan Doyle made fun of this whole situation. But as you can imagine, the idea of making money in this fashion appealed to some Americans, especially to John Romulus Brinkley, who had purchased a medical degree. And in those days, you could do that. There were all kinds of quack colleges where by mail order, you could do some sort of quick fill-in questionnaire, and you would get a medical degree. And Brinkley, therefore, was able to call himself doctor, and he decided that he would capitalize on this whole gland transfer idea. He had grown up on a farm, and he had seen the vigorous activities of goats, and he had noticed that they were rather horny. So, of course, he did not have access to human testes to transplant, obviously, and there were no monkeys available either, but there were plenty of goats available. So Dr. Brinkley became the goat gland doctor, and he specialized on transplanting goat testicles into humans, into men. There was no shortage of participants in this. He carried out some 1,700 such operations, which apparently he did with some surgical skill because he didn't have many complications. Of course, he never tried to connect the testicle to anything. He just inserted it into the scrotum. In any case, this carried on for years. And one of the most famous stories was about a farmer that came to him complaining that his wife had called him a flat tire, and he wanted a solution. So, of course, Brinkley offered the solution that he always offered, which was a goat-to-man transplant. And he did. And he got a letter from the guy a year later saying how pleased he was, how much better he felt. And even more, he had been able to father a son, for which he really thanked Brinkley. And in his honor, he gave the name Billy to the son after the supposed billy goat that had donated the organ. So anyway, the story of hormones evolves, and I mean we're still in the 1800s, and it was much later that we really began to understand the intricacies of the endocrine system and how it works, because it required careful analysis and careful dissections of the body, especially of the brain. And that's when the pituitary gland was discovered. The pituitary is a tiny little gland almost smack in the center of the brain. And if you want to see what it really looks like, I'll show you really an amazing picture. That is the pituitary gland, which is like a pea, even smaller than a pea, sitting in the brain. How do you get a picture like that? Through an optical fiber with a tiny little lens at the end. So you're actually looking into the brain. The pituitary gland produces a whole range of hormones. Collectively, though, the amount that is produced is about 1/1,000,000th of a gram of hormones per day. 1/1,000,000th of a gram you would not even be able to see. It is so small. And yet, there's no life without it. It's critical to life. So this is always an interesting thing to note. because, you know, in toxicology, we always talk about the dose being the poison, right? I mean, this is Paracelsus's old dictum 500 years ago. Only the dose makes the poison, which of course is true. And very often, when someone is exposed to a very small amount of something, you know, people tend to say, well, it's irrelevant because it's so little, it can't do any good. But that's when I always, you know, remind them of the fact that a few milligrams produced by the pituitary gland is critical to life. So very small amounts of substances can still have an effect. The pituitary is sort of the conductor of the hormonal orchestra because it releases hormones that will then trigger other parts of the body, other organs into activity. For example, it releases ACTH, which activates the adrenal glands, tells them to produce adrenaline. It releases growth hormone, which tells our muscles to grow. It releases thyroid hormones. It triggers the release of hormones that involve the sex organs. So the pituitary gland is tremendously important. And if it functions properly, then you're in good health. If it doesn't, there are all kinds of problems. For example, the pituitary gland produces prolactin, which is the hormone that is needed to make milk after baby is born. Somatotropin is growth hormone. I mentioned the adrenocorticotropic hormone, the hormone that causes an egg to be released in order to achieve pregnancy. Thyroid stimulating hormone. So obviously the pituitary is critical. How, for example, does the breast know to produce milk when the baby wants to drink? It is the pituitary that sends the signal. Now, if there's a problem with the pituitary gland, that can have several different kinds of manifestations. For example, if there is too much pituitary growth hormone produced or too little, that has very obvious consequences because growth hormone, as the name implies, controls growth. So if too much somatotropin is produced, you get something called gigantism. If too little, it is dwarfism. Dwarfism is actually an acceptable term to use medically. The term that is not acceptable is midget. Okay, but dwarf is, although that usually is not the term that is used today, the more acceptable term is of short stature. There are dwarfs who, of course, are perfectly normal in all of their bodily dimensions. One of the most famous ones was General Tom Thumb, who made the tour around the United States. He became extremely famous thanks to this man. Anyone recognize him? P.T. Barnum, exactly. P.T. Barnum was a great showman. He was always looking for things to exhibit, and the General Tom Thumb was one of his prime exhibits. As I said, if you have excess growth hormone, it causes excessive growth. And the largest woman ever was because of excess growth hormone due to pituitary malfunction, and that was Sandy Allen, who I did meet, as you can see. And notice her spectacular size. This was at the Guinness Museum in Niagara Falls, where basically she was an exhibit, including her car, which was a normal car with the front seat completely removed. So she would sit on the back seat because her legs reached the pedals, and she had an extension of the steering column. But as you can see, she died at a rather young age, but she was really very, very nice, as I remember, and very impressive. The tallest man who ever lived was also due to excessive production of pituitary hormone, and that was Robert Wadlow. And you can see his size besides the midget there. And he did not live that long, as you can see, because, of course, the heart has to work very hard to keep pumping the blood to those heights. Another manifestation of excessive growth hormone is something called acromegaly. And this happens when the pituitary gland starts to produce excessive amounts due to a tumor, but after the body has fully grown in terms of height. And then acromegaly sets in. And that's the condition that Andre the Giant suffered from. And he had a pituitary tumor and eventually died of heart disease. He died in bed, actually. He was in his 40s. But he was a huge wrestling star, I mean, in Montreal. Although before he became a big star as Andre the Giant, he was a pretty big star in Montreal under a different name. Anyone remember that? Jean Ferret. Very good. Yeah. He was known as the Giant Jean Ferret. Yeah. And I guess that didn't go over well in the States, so they changed his name to Andre the Giant. So pituitary hormone deficiency can cause dwarfism, as I said, although really we should refer to this as people of short stature. And these days, this can be treated because pituitary hormone can be extracted, mostly from pituitary gland of cadavers, and it can be used to treat children who suffer from pituitary deficiency, and they will then experience normal growth. It's much safer today than it used to be because when you extract pituitary gland hormone, it is also possible sometimes to extract viruses, bacteria that may have infected the gland. But today, this is all done by genetically engineering techniques because the gene that codes for the production of growth hormone has been isolated, cloned, and it can then be inserted into the genome of bacterium, and the bacterium will then grind out growth hormone, and you don't have the problems of cadaver. So human growth hormone today can be made by genetic engineering techniques. Now, there's something very interesting as a possibility with human growth hormone. As we age, the body produces less and less of this hormone because less is required when we finish growing. But the question arose of what if we don't allow the levels of the growth hormone to drop? Why did that question arise? Because anytime you look at something that decreases with age, you start wondering, could it have some benefit if you don't allow it to decrease with age? So this is what was investigated by Dr. Daniel Rudman, and the results of his study were published in New England Journal of Medicine in 1990. New England Journal of Medicine is really the Bible of medicine. And anything that appears there, you know, is pretty legitimate research. It has the highest rejection rate of any scientific journal. Rejection rate is the number of papers that are accepted relative to the ones that are rejected. But most of the ones that are rejected are still very, very good and eventually end up being published in other journals. So there are many papers that are just not good enough for the New England Journal, but are still okay for other journals. So anyway, the reason I mentioned that is to underline that if it's in the New England Journal, you pay attention to it. So Rudman and his crew described how they had been treating volunteers, men in their 60s and 70s and 80s, with human growth hormone to see what would happen. And the results were pretty good. The men said that they felt better. That doesn't mean much, of course, because that could be due to the placebo effect. But they actually did some measurements. And they found that there was an increase in muscle mass, decrease in fatty tissue, increase in skin thickness, and increase in the average density of vertebrae. All of these are good things, right? Because we associate those with more youthfulness. And as you can imagine, the press, of course, loved this story. And there were all kinds of articles that, maybe the fountain of youth has finally been found. However, this paper was published 6 months into the experiment, but they still kept monitoring the patients after. And they noticed that as they kept monitoring, their blood pressure increased, plasma glucose increased, they started to develop carpal tunnel, and also breast enlargement, none of which was desirable. Of course, the press never talked about that. They already had their story. They had, shown this to be the miracle against aging. So Rudman had to do something which was quite unusual. He wrote a letter to the New England Journal, where the original paper was published, and described, "We and others have proposed the use of recombinant human growth hormone therapy for the elderly in an attempt to retard the undesirable changes in muscle mass and function, body fat, bone mineral contents associated with advancing age, and the subsequent impact these have on healthcare costs. Our initial enthusiasm for this idea has declined as a result of an unexpected high incidence of side effects." Of course, that didn't get much publicity. No, it's the original story gets the publicity, and then when you have to attenuate the story, it gets much less. Anyway, the fact is that there is no measurable permanent improvement with this, but that did not stop, once again, the charlatans from getting in on the game. Because if you can refer to something published in the New England Journal, it's an open ticket to charlatanism. And a number of clinics began to open up, claiming that they have human growth hormone and they can rejuvenate people. Now, this was doubly wrong. First of all, because the real growth hormone didn't really rejuvenate. But furthermore, the problem was that it was impossible for them at that time, in the 1990s, to have growth hormone for what they were charging. I mean, they were still charging enough. They were charging a couple of $1,000s for this. But at that time, the growth hormone, which was being made by recombinant DNA technology, was very rare. In Rudman's experiment, it cost $18,000 per each patient. So whatever these charlatans were injecting was not growth hormone. So it was, doubly fraudulent, because even real growth hormone would have not done what they claim, but they weren't injecting real growth hormone. Today, of course, the technology has advanced significantly, and it is possible to make growth hormone in pretty significant amounts through genetic engineering. And it is marketable. There you have it, recombinant growth hormone. So in the case that anyone does suffer from pituitary deficiency, now they can be readily treated with growth hormone. However, the idea that it increases muscle mass is still around. And there are people who use growth hormone, who inject growth hormone in order to try to increase their muscle mass. Sylvester Stallone is a great proponent of this. He's in pretty good condition, muscular-wise, looking at his age, but it comes mostly from exercise, not from the growth hormone. But nevertheless, he's a big promoter of it. There's another gimmick that is used in connection with growth hormone. Growth hormone is a protein. It's a pretty complex molecule. And although it's now more readily available because of the recombinant DNA technology, it's still relatively expensive. I mean, you still, you don't go into the health food store and find it on the shelf. But you can go into the health food store and find what they call growth hormone activator or growth hormone secretagogue. And the argument that they use here is that it will trigger the production of growth hormone by the body. And they're very clever with their wording. This is how it goes. They will tell you that human growth hormone is a protein, which is true. That proteins are made of amino acids. That's what proteins are. They're amino acids that are joined together like links in a chain. So you can, in fact, analyze what amino acids are present in human growth hormone. This is well known. So what do they have in here? They have those amino acids. And the idea is that the body will therefore use those to make growth hormone. It sounds logical, unless you know the science. The reason that the body produces less growth hormone as we age is not because it doesn't have the raw materials. We eat enough proteins, which the body breaks down to amino acids. We have a huge supply of amino acids in our body. The problem is that the enzymes that take those amino acids and build them into a protein don't function anymore. So their argument really is like taking a truckload of bricks, truckload of windows, truckload of doors, dumping them on an empty lot, and waiting until they assemble themselves into a building, right? You're going to have a long wait because you need the people to do it. Well, the same thing in the body. The reason that we produce less growth hormone is not because of a lack of raw material. There is no reason other than, anecdotal from people like Sylvester Stallone that there's a reason to use growth hormone. Okay, moving down the body a little bit, we'll get to the pancreas. And one of the most famous hormone-generating organs, of course, and you know where it's located. It's right under the liver. This is what it actually looks like. There's a real pancreas. And the best way to describe what a pancreas does is that it is the cell's gatekeeper for glucose. Glucose is needed by every single cell in our body. It is the raw material that is used to produce energy. Basically, the body is a combustion machine. We inhale oxygen, we use the oxygen to burn the glucose, we exhale carbon dioxide and water, but we also, in that sequence of reactions, we produce the energy that is needed to run our body. If there is no glucose that is available, you die. And insulin is critical in allowing glucose to enter the cell to carry out the reactions that basically constitute life. Well, prior to the amazing discovery by Charles Best and Frederick Banting, Canada, at University of Toronto, diabetes was a death sentence. It was very rare that any diabetic, juvenile diabetic or type 1 diabetic would live into their 30s. They would die before that. But Banting and Best discovered that the insulin that is released by the pancreas can be used to treat diabetics. This research was carried out on dogs. And this is also a very important story to tell, the fact that it was carried out on dogs, because as you know, there's a lot of opposition to doing animal research. PETA, the People for the Ethical Treatment of Animals, are against using any kind of animal for any kind of research. The fact is that you cannot do medical research without using animals. First of all, you certainly, when you're studying toxicity, you have to use animals to determine if something has potential toxicity. And if it weren't for the dogs, we wouldn't have insulin. So anyway, they were able to isolate insulin from the pancreas of a dog. And pretty soon, Connaught Laboratories in Toronto was producing insulin, and they were producing it from a pig pancreas. This was a huge undertaking. Thousands of pig pancreas were needed to finally extract insulin and purify it. And it went on the market as hog insulin, which is almost identical, but not exactly identical to human insulin. And there were some side effects to using this, but of course that really was insignificant in comparison to what insulin was able to do. It saved the lives of diabetics. And today, of course, with proper monitoring of blood glucose and use of insulin, diabetics can lead as long lives as anyone else. And this was one of the greatest breakthroughs in the history of science, is the discovery and the use of insulin. And for this, Banting shared the Nobel Prize. And Canada, of course, has become world famous because of, at least in medical circles, because of the discovery of insulin. Today, insulin is also made by genetic engineering techniques, and no longer do we have to extract it from the pancreas of animals, because the gene that tells the body to produce insulin has been identified, it has been cloned, that is made to multiply, inserted into bacteria, and the bacteria then grind out human insulin, which has very, very low chance of adverse reactions. This was really a major Canadian discovery. Well, moving even further down the body, we get to the gonads, the testes in the male and the ovaries in the female. And these are what make men into men and women into women. And if you want to get down to the molecular level, it is all a question of testosterone and estrogen. Estrogen is the female sex hormone, testosterone is the male sex hormone. These are responsible for the secondary sex characteristics, for the growth of breasts, for muscle distribution, etc. But both men and women have both of those hormones, but of course in different proportions. And it's the balance of those hormones that determines whether we are men or women. And of course, there is that very interesting situation that these days gets a great deal of publicity, is people who believe that they are born into the wrong body and want to undergo procedures that will allow them to lead a happier life. And those procedures, of course, do involve hormones. When you're talking about a sex change operation, hormones are intimately involved. When someone is transferring from a woman to a man, then you have to use testosterone, and the other way around, you have to use the female hormone, estrogen. And of course, the classic case here, I guess the sort of prototype case that everyone talks about, is that of Bruce Jenner, who in 1976 won the decathlon here at the Olympics. And I remember that very well because I was there. And I remember him winning and wrapping himself in the American flag and going around the track. And I can tell you that no one at that time would have ever believed that he would become Caitlyn Jenner. I mean, we didn't think of things like that. But in this transformation, you need to use hormones. So estrogen would be injected. And that changes the way the hair grows, it changes the hair distribution on the body. And as you can see, she now looks totally like a woman. They've never talked about whether or not there was any surgical procedure in her case, and to what extent Bruce became Caitlyn. Because obviously there are potential surgical procedures if you want to go a little bit further than just hormonal treatment. And those surgical procedures have actually become very sophisticated. where they can remove the male organs and actually construct the female organ functioning, obviously not pregnancy, but otherwise. You can also go in the other direction. Here, of course, surgery is required to remove the breast, but then you use testosterone in order to increase muscle mass. And the results really can be, quite amazing when you do the testosterone. And today, testosterone is available for injection. And there are some men who believe that it's also going to make them more manly if they get more of this male hormone. And some people actually do have low levels of testosterone, but the only way you know that is by having a blood test and knowing. And in that case, it is possible to use testosterone as a treatment. However, there are potential side effects here, because testosterone in the body gets converted into dihydrotestosterone, which causes an enlarged prostate. And in fact, a drug that many of you may be familiar with, Proscar, which is finasteride, reduces prostate size by blocking the conversion of testosterone into dihydrotestosterone. So, before resorting to testosterone treatments and asking doctors for that, you also have to consider the potential side effects on the prostate. But a blood test will reveal whether or not this is something that should be pursued. There are also drugs that block the action of testosterone. They're called anti-androgens. And these are used in the treatment of prostate cancer because the male hormone can increase the risk of prostate cancer. So one of the drugs that is used is cyproterone acetate, which is an anti-testosterone drug used in the treatment of prostate cancer. But it can also be used in the treatment of sex offenders, because this is something that is referred to as chemical castration. So if they are committing sexual crimes because the blood testosterone is too high, they're given cyproterone acetate, which cuts down their urge to perform these things. But there's a sort of a sad history to this, about using these anti-androgens to reduce testosterone levels. And that is the story of Alan Turing. Alan Turing was a British scientist. He's constantly referred to as the father of computer technology. He devised really the first computer that you see here, which was used to uncode coded messages that the Germans were sending. The Germans had this Enigma machine that sent coded messages, and Turing was the one who was able to decode that. It was tremendously important to the Allied effort during the Second World War. But he was gay. And in those days, in the 1940s, this was unacceptable in Britain. In fact, it was a crime to be gay. And he was given the chance of either going to prison or undergoing chemical castration, that is, being injected with cyproterone acetate, which is what he chose. But he ended up committing suicide because he couldn't handle the consequences. There's a classic statue of Turing in Manchester, right next to the University of Manchester, where he worked. And there he is, sitting on a bench, holding an apple. And there's been some, interesting conjecture about why he's holding the apple. And some say that it is because it represents Newton's apple and, great discovery, which, his was. But there's also the suggestion that he committed suicide with cyanide, and the cyanide was put into an apple, which was found beside his bed. That was never totally confirmed. They did find cyanide in his body, but whether it came from the apple or not. But anyway, that's the controversy here. There are also some people who suggested that Steve Jobs took the Apple logo because of this story, but Jobs said that that's not true. He didn't have Newton in mind. He didn't have Turing in mind for that logo. Now, these steroids, like testosterone, are also known as anabolic steroids because they can actually build muscle mass when injected. And of course, this is the story of all the athletes who have used steroids in order to improve their performance, which it can do. And of course, we have a Canadian legacy with that as well, right? With Ben Johnson. And you remember how excited we were in 1988 when he won the 100 meters at the Seoul Olympics. Now, the 100-meter run in the Olympics is the Olympics' premier event, right? It only takes 10 seconds, but it is the event of the Olympics because it determines the fastest human in the world. And it turned out, of course, that not long after, he was stripped of the gold medal because it turned out that he had been using stanozolol, which is an androgen. It's a testosterone-like drug. And at first, of course, he denied it, but later they admit it. And this was his fall from glory. Of course, it is still done. The Russians are masters at this. They are tremendously adept at cheating. And the East Germans at that time also were, but it was always the Russians behind it. The female hormones here are estrogen and progesterone. And as I said, these determine the secondary sexual characteristics. But it's also interesting how they change in concentration during the menstrual cycle. First, estrogen rises, and around the mid-cycle, it starts to go down. And you can also see that progesterone follows a very similar sequence, unless there is pregnancy. And when there is pregnancy, then the progesterone level does not decline. And that is what prevents a second egg from being released. So that's why progesterone is called the pregnancy hormone. And this is what gave rise to the idea of the birth control pill. Why can a pregnant woman not get pregnant again, right? I mean, today we know that this is not possible, but why should that not be possible, right? Why should you not be able to get pregnant and 3 months later get pregnant again, another 3 months later get pregnant again and produce an assembly line? Because the body says no. Let's get this bun out of the oven first before we get into this lunacy again, right? So how does that happen? Because when you're pregnant, levels of progesterone rise, and the body senses that, and it prevents the release of the messenger, the hormone from the pituitary gland that tells the ovary to release an egg. So no egg is released. And of course, if no egg is released, because of the presence of progesterone, you cannot get pregnant. So this is what gave rise to the idea of the pill. Could you inject progesterone into someone and prevent pregnancy, right? Is the body going to know that this comes from an external source? Well, in order to do that experiment, you have to have some progesterone. The amount that is found in the urine of a pregnant woman is very small, whereas you could find a lot in pigs because you can raise a lot of pigs. So at first, progesterone was extracted from pigs, and it turned out that it actually did in rabbits block pregnancy. And and if you can do that in rabbits, you know that you're on the right track, right? But still, they wanted progesterone from a human source. Where do you get it? Well, you get it from the urine of pregnant women. How do you do this? So the company made a deal with milk delivery company, because in those days milk was still delivered. And the idea was that if a pregnant woman would leave a bottle of her urine on the doorstep, When the milkman came, he would take it and leave her a free bottle of milk. So they were able to collect a lot of pregnant urine like that and extract the progesterone. But as you can imagine, the milkmen did not relish doing this, carrying all this urine. So they had to be compensated. So they were paid for every bottle of pregnant urine they brought back, which means that it was in the interest of milkmen to have as many women pregnant as possible, which is where the expression, the milkman did it, came from. But the real key to solving this problem was Russell Marker, a chemist, who had discovered that a plant that grew in Mexico called Mexican yam produced a compound called diosgenin, which could be converted to progesterone. Now, progesterone is a steroid, pretty complex molecule. The only trouble was that in order to prevent pregnancy with progesterone, it had to be injected. And that was not acceptable. Most women would not want to inject progesterone on a daily basis. So the question was, could you convert it into an oral form? And that meant playing around with the structure of the molecule until they came up with Norlutin, and that was the ingredient in the first birth control pill. And it worked because it basically confused the body into thinking that a pregnancy was underway. And if a pregnancy was underway, then there was no second egg released. Now, finally, there's yet another use for female hormones, and that, of course, is in estrogen therapy. When women reach the age of menopause, the amount of estrogen that their body produces decreases, and this has consequences, because estrogen is important in bone formation, and of course, we know that osteoporosis, osteomalacia are more prominent after menopause. So the question is, can you reduce the problem here by taking extra estrogen to compensate for what the body is not producing? And the answer is yes. Premarin is the drug that was developed for this. It was perhaps an unfortunate name, although a clever name. Premarin comes from pregnant mare's urine, and that's where the estrogen is isolated from. And this, of course, did not go down well because people didn't want the urine of horses injected or used in the pill form. Of course, the fact is that although it was extracted and still is extracted from urine of pregnant horses, there are huge horse farms in Alberta where they take the urine and convert it into estrogen. And of course, it is highly purified. There's no remnant of the horse urine in there. Now, there are, of course, contraindications. People who have history of migraines or stroke, kidney disease, they cannot use estrogen supplements. And there are also some concerns with using estrogen. It can slightly increase the risk of cancer. And much has been written about this, the so-called the truth about hormones, etc. And many women have shied away from using estrogen supplements because of the concern about increased risk of cancer. Well, let me just finish our discussion here today by telling you just how one looks at that risk and how one calculates it. Put it into realistic terms. The frightening statistic that you will often see that turn women away from using estrogen supplements is that it increases the breast cancer risk by 30%. So if you're told that, I think you're likely to take your estrogen supplements and look for the nearest garbage can, right? 30% increase in cancer risk seems to be pretty large. However, let's look at this more realistically. In the 10-year period after menopause, the risk of breast cancer, irrespective of whatever you may use, is about 3 to 4%. That is, out of every 100 women in the first 10 years after menopause, 3 or so will develop breast cancer. That's the statistic. If you're using estrogen supplements, that increases to 5%. So you see the 30% increase is from, let's say, 3.5 to 5. That's your 30% increase. But the fact is that you could also say that a postmenopausal woman who takes estrogen reduces her chance of remaining cancer-free from 96 to 95%. If you look at it like that, you say, well, so what? That's insignificant. This is why it is very important to speak in terms of absolute risks and not percentage risks, okay? Because percentages can be very misleading, right? If you buy 2 lottery tickets instead of 1, you've increased your chance of winning by 100%, but it's meaningless, right? Because an increase in a small number still leaves you with a very, very small number, right? So more realistically, if someone has reached menopause and they are concerned about menopausal symptoms and they want to take estrogen, the risk that they're taking is roughly 1 in 100. 1 in 100 women who are taking estrogen, menopause, will develop breast cancer. Now, 1 in 100 also sounds very small, right? Which it is. But when you're talking about millions of people taking this, you're still talking a large number. But still, when you make such decisions, it's important to be realistic and have the right numbers. Then, of course, there are the so-called natural estrogen supplements sold in health food stores. This is all nonsense. There's no evidence that any of these can do any good. If you really are into wanting estrogen supplements, you have to go for the pharmaceutical, you have to go for Premarin, and it can have some pretty good changes in life, right? Estrogen really does have a certain amount of rejuvenating effect, but there are risks. But then again, everything in life comes down to evaluating risks and benefits. So that's the story of hormones. And I think it's an interesting story, historically, and also in terms of how we use them today. And also something that is important to take into account, that we started this story basically, 120 years ago. So all of this knowledge we have gained in the last 100 years. So you can imagine what is going to happen in the next 100 years, right? Yeah, good question. The question is whether or not someone who, let's say, has pituitary deficiency and they've not grown high enough, does that mean that their organs inside also proportionately have not grown? No, actually, when you use growth hormone, it will fix it all. It will cause their organs to grow at the same rate as the body grows. Yeah, I don't know about the size of his heart, but obviously you need a lot more pumping power to reach that height. So his heart wasn't capable of doing it. Yeah. Yeah, if you could do that, you would rival Tesla for being the richest person in the world. Yeah. Yeah. No, I can tell you that there's tremendous amount of research on that. Hasn't been successful. there are a couple of drugs that are somewhat successful in growing hair, and one of them is finasteride, which is the same drug that I talked about that is actually used to treat benign prostate growth, that also encourages hair growth, and that is used. But the success rate is 8 to 10% of people who use it are satisfied. But there's really nothing that will grow a luxurious hair. But boy, is there ever a lot of research in that. I mean, you can imagine the amount of money that can be made if you find something that really works. Yeah. Yeah, but I mean, it's rare that you're happy with your menopausal symptoms until 70 and then decide that you're not happy, right? So that's usually not how it works. It's usually when you reach menopause that you discover that maybe this is not such a great thing. That's when you go for it. So I'm not aware of people starting estrogen in their 70s. Yes. Yeah. 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 I don't think so. But again, I don't think that that's really been studied because it's not something that people would normally do. Yeah. Immunity. Okay, because it wasn't attached to anything. Okay, it wasn't getting into the bloodstream. It was just located in the scrotum. It didn't do anything. If you were to somehow attach it to the bloodstream, yes, then you'd have some sort of immune reaction. And anyway, I mean, whether or not some people had immune reaction, who knows? They didn't keep proper statistics on these things. I'm sure that there were a lot of men who were not happy with this, and who could have had reactions, but you never heard about it. It wasn't record keeping, wasn't. All right, so I will see you next year, right? Which is the first Monday in January 4th, I think, something like that. All right.